In this video, we shall be looking at balancing of chemical equations. So let's start by taking some few examples. So we have propane burning in oxygen to give us carbon 4 oxide and water. Now, first and foremost, you have to make sure that both sides of the equation have the same number of atoms. So in this kind of combustion reaction, we first balance the carbon, then we'll balance the hydrogen before balancing the oxygen. So let's look at the carbon. We have 3 carbon here and we have only 1 here. So we'll just add 3 here. Next, let's balance the hydrogen. So we have 8 hydrogen here and we have 2 hydrogen here. So what we'll do now is say 2 divided by 8 is 4. So we'll put 4 here. So we have 8 hydrogen in both sides of the equation. Now let's balance the oxygen. Now we have 6 oxygen here because 3 times 2 is 6. And we have 4 oxygen here. 4 plus 6 is 10. So we have 10 oxygen at this side of the equation. So what we'll do now, we'll say 10 divided by 2 because we have 2 at this other side is 5. So we'll put down 5 here. So now this equation is balanced. Let's check. We have carbon. We have 3 here and we have 3 here. Hydrogen. We have 8 here and we have 8 here. Oxygen. We have 10 here and we have 10 here. So our equation is balanced. Let's take another example. Butane plus oxygen will give us carbon 4 oxide and water. Now let's first balance the carbon before balancing the hydrogen and then the oxygen because this is also a combustion reaction. So we have 4 carbon here. We'll add 4 here to make 4 carbon in the other side too. Now we have 10 hydrogen and we have 2 hydrogen in the other side. So what we'll do, we'll say 10 divided by 2 is 5. So we'll put down 5 here. Next, we'll balance the oxygen. We have 8 oxygen here and we have 5 oxygen in the other side of the equation. That makes it 13. But then we'll have 2 oxygen in this other side. So we'll say 13 divided by 2. Since 13 can't divide 2 directly, we'll just put down 13 divided by 2. Right? But now, in writing chemical equations, you cannot use fractions. So to be able to eliminate this fraction, we'll multiply the entire equation by 2. So we'll say 2 multiplied by C4, we have 2C4 H10 plus 2 multiplied by 13 all over 2. Then we say 2 times 4 is 8 plus 2 times 10 times 5 is 10, sorry. Right? So the 2 will cancel this 2. So what will be left with now? 2 butane, 13 oxygen, and then we'll have 8 carbon 4 oxide and then 10 molecules of water. Now let's be sure if our equation is balanced. For carbon, we have 8 carbon. 2 times 4 is 8. And for this other side of the equation, we have 8 carbon. Then we have for hydrogen, we have 20 hydrogen. 2 times 10. And then this other side of the equation, we also have 20 hydrogen. Then for oxygen, we have 26 this other side because 13 times 2. 8 times 2 is 16. 16 plus 10 is 26. So our equation is balanced. Let's take another question. Let's say we have aluminium plus HCl. Then we have aluminium chloride plus hydrogen atom. Now if you are wondering how I'm able to write this chemical equation, I've treated a video that talks extensively about writing of chemical equations. So you can just go to my channel and check that out. Now how do we balance this particular equation? If you look at the equation closely, you know we have uneven numbers of chlorine atoms in the equation.
Therefore, since we have 3 chlorine at the right and 1 chlorine at the left, we'll say 3 divided by 1, the answer is 3. But we will not be putting 3 in front of HCl due to the even odd situation in the equation. But what we'll be doing is multiplying both sides of the equation, compounds containing chlorine, by 2. So we'll say the 3 that we're supposed to put in front of HCl multiplied by 2 will have 6. And then HCl we have 1 in front of it. 1 multiplied by 2, we have 2.
Next, we'll balance the aluminium. We have 2 aluminium here, so we'll put 2 here. Next, we'll balance the hydrogen. We have 6 hydrogen here and we have 2 hydrogen here. So 6 divided by 2 is 3. So we'll put down 3. Now our equation is balanced. Let's check. Aluminium. We have 2 aluminium here. We have 2 this other side. Let's check hydrogen. We have 6 hydrogen this side. We have 6 hydrogen this side. Chlorine. We have 6 chlorine this side. And we have 6 chlorine the other side of the equation. So our equation is balanced. Let's take another question. If you look at this equation carefully, you will see that we have 3 bromine atoms in this other side of the equation and 2 at the other side of the equation. So we have odd even situation, right? Now, when you have this odd even situation, what we'll do first, we'll look at the LCM of 3 and 2. So the LCM of 3 and 2 is 6, right? Therefore, we say 2 divided by 6 is 3, right? So we'll put 3. And we'll say 3 divided by 6 is 2. So we'll put 2. Next, we'll balance the gallium, right? So we'll say we have 2 gallium, we'll put 2 here. Next, we'll balance the copper. So we have 3 copper here, we'll put 3 here. So our equation is balanced. Let's check. For gallium, we have 2 here and we have 2 here. For copper, we have 3 here, we have 3 this other side. For bromide, we have 6 this side and we have 6 this side. So our equation is effectively balanced. Let's look at another question. Now, how do we balance this particular chemical equation? See, we have uneven number of fluorine atoms also in this equation. We have 2 fluorine atoms and then we have 7 fluorine atoms on this other side. So for us to balance this equation, we'll look at the LCM of 7 and 2. So the LCM of 7 and 2 is 14. So we'll say 2 divided by 14, we have 7, so we'll put 7 here. So and then we'll say 7 divided by 14, we'll have 2, so we'll put 2 here. Now, let's look at the equation. For iodine, we have 2 iodine, we have 2 iodine. For fluorine, we have 14 fluorine here, and we have 14 fluorine here. So we have double replacement. So let's say reaction. Iodine. Now, in this type of reaction, we have 2. Fluorine, we have 14, and we have 14. So our equation is balanced. Let's take another question. You don't have to balance each atom individually, because when you look at this particular kind of atom, this PO4, this is known as phosphate, and this can be balanced as a single unit, right? Because it's a polyatomic ion. Now, to balance this particular equation, let's start with the polyatomic ion first. We have 2 PO4 in this side. So what we'll do is we'll add 2 here to balance it up. Next, let's balance the sodium. So we have 6 sodium here. 2 times 3, 6. So we'll put 6 here because we only have 1 here. So we'll put 6. So our sodium is balanced. Now, what we'll do next is to balance the chlorine. So we have 6 chlorine here and we have 2 here. 2 divided by 6 is 3. So we'll put 3 here. Now, our chlorine 2 is effectively balanced. So let's balance the magnesium. We have 3 magnesium here. So our equation is effectively balanced. But let's check sodium. We have 6 sodium here. We have 6 sodium here. Phosphate. We have 2 phosphate here. We have 2 phosphate here. Magnesium. We have 3 magnesium here. We have 3 magnesium here. Chlorine. We have 6 chlorine here. We have 6 chlorine here. Let's look at another question. Now, this is also a double replacement reaction, similar to the one we just treated earlier. So in this case, the sulfate, which is SO4, should be treated as a single unit. So therefore, let's start by balancing the polyatomic ions, sulfate. So we have 3 sulfate here, and we have just 1 here. So we'll put 3 here to make it balanced. Next, we'll balance the potassium. We have 6 potassium here, and therefore we'll add 6 here to balance the potassium. Next, we'll balance the chlorine. We have 6 chlorine here, and we have 3 here. So 3 divided by 6 is 2. So we'll put 2 here to balance the chlorine. Now we have 2 aluminium here and we have 2 aluminium here. So our equation is effectively balanced. Let's check to confirm. For sulfate, we have 3 in this side of the equation. We have 3 in this side of the equation. For aluminium, we have 2 in this side of the equation and we have 2 in this other side of the equation. For chlorine, we have 6 in this side of the equation and we have 6 in this other side of the equation. For potassium, we have 6 in this side of the equation and 6 this other side of the equation. So that will be all for this video. Thank you so much for watching. Please do like, share, subscribe, and drop your comments at the comment section. If you have a question, please write down your question at the comment section below. And please, in case you have a topic that you don't understand, maybe I have not treated the topic in this particular video or any of my videos, and you want me to look at the topic for you, you can please write down the name of the topic